All right, guys, welcome back. We're going to do 5-3 today, which is all about medians and altitudes. So this is something, again, we haven't talked about yet, so we're going to have new vocabulary again today. We actually have 3 objectives for today, so we're going to identify special segments in triangles and understand theorems about them. So we're going to learn about what is an altitude, what is a median, what is a centroid, and so on and so forth. We're going to find and use the point of concurrency for the medians of a triangle to solve problems. And then we're going to find the point of concurrency of the altitudes of a triangle. So lots of new vocabulary, right, in those objectives. So we're going to go over those first. We have 4 new vocabulary here: altitude of a triangle, centroid of a triangle, median of a triangle, and orthocenter of a triangle. And then our 2 postulates are concurrency of medians and concurrency of altitudes. So we're going to look at when all 3 of the medians join at a point, what happens, and when all 3 altitudes join at a point, what happens. So we're going to jump down now to our terms and vocabulary pages in the back of our packet so that we can go over this new vocabulary. All right, so here we are on the terms page, and we're going to finish out our terms today. We're going to start with the altitude of a triangle. So if I have a triangle, my dogs are going to start playing, because why not? So the altitude of the triangle is a line segment that goes through a vertex, and it's perpendicular to the opposite side. So I'm just going to label this triangle. So I can draw it from vertex A, vertex B, or vertex C, but I'm just going to draw it from 1, just for the example here. So it needs to go through the vertex, and it needs to be perpendicular to the opposite side. So in this case, that is the altitude. And we can call this D, right? So BD is the altitude. And again, I could draw it from A as well, right? As long as it's perpendicular. Or I could draw it from C, as long as it's perpendicular to that opposite side. The next one is median. And median is, so let's draw a triangle, but oh boy. The median is from a vertex, you just go to the midpoint of the opposite side. So here, again, I can draw it from all 3 vertices, but I'm only going to draw it from 1 just for the sake of this example, okay? So I want to find the middle. If I'm going from vertex B, I want to find the middle of AC, which to me looks like around there, right? And I'm just going to connect it. And again, this is something that I can do on the other side too, right? This looks like about the middle to me, so I would connect A to that point. Or here, I would connect C to that point. But here, BD is the median. So what happens here is if I draw all 3 medians, it's called the centroid of the triangle. So I'm going to draw this same triangle again, or at least I'll try to, right? And I'm going to label it. And now what we're going to do is we're going to draw all of them. So this looks like about the median. So there's one median, excuse me. And here, oh boy, that was awful. There we go, that's okay. And then the last one. It's so much easier when you can turn your paper and actually draw it kind of straight. So my apologies. Okay, so the center where these guys meet right here is called the the centroid. Right? Holy moly, spelling. Centroid. And so it's just a point of concurrency, right? It's a point where the 3 lines intersect. And it just has a special name called the centroid. The last term that we're going to go over is the orthocenter. And this is the point where all three of the altitudes meet. So I'm going to draw a triangle. It kind of looks like an equilateral. Or, yeah, this is not my intent, but that's okay. And we're going to draw the altitudes here. So remember that when we draw the altitudes, it has to be perpendicular to the opposite side. Like so. And the center here, where those 3 points meet, is the orthocenter. So that is the point where all three of the altitudes meet. So what we're going to do now is we're going to go over to our theorems and postulates page, and we're going to look at what happens when all of the medians of the triangle join together, and there's a very special relationship that happens. So let's go to our theorems and postulates page and look at that. All right, so here we have our concurrency of medians. So the definition seems a little confusing. It says the medians of a triangle are concurrent at a point, right? So they all meet at one point. That is 2/3 the distance from the vertex to the midpoint of the opposite side. You're like, what the heck is it talking about, right? What we're going to do is we're going to draw this out, and then we're going to label it very carefully, and hopefully you'll see that it's not so bad. I'm going to kind of draw this big, just so it's a little bit easier to see. All right, so I'm going to label this A, B, and C. Okay, so I'm going to draw the median. So remember, median means you find the halfway mark of the side opposite, and then we connect it to the opposite vertice. So there's one median. This looks like it's about in the middle. Holy moly, there's another median. And then somewhere in here. There is our last median. Okay, and I'm going to label this point D. Then I'm going to go over here and label this E, this F, and this G. So kind of notice, it's easy to see here on A to E that one part of that line A to E is shorter than the other part, right? So like here DE is shorter than AD. And so what happens is if I take DE, so the length of DE, whatever that is, and I multiply that by 2, I get the length of AD, which is this guy right here. So this length right here, DE, times 2 gives me AD. And that's the same for all of these. So 2, if I take the length of DF, which is the shorter side, I know it's hard to see because I'm a terrible artist, but so this DF, if I multiply that by 2, I'm going to get BD. I'm going to get this length right here. Okay, so DF times 2 equals BD. And then same thing here, if I multiply G or DG by 2, so this short end, right? If I multiply that by 2, I'm going to get the side length CD. So that's all that means, is that if I take the shorter length and I multiply it by 2, I get the longer length. But that only works when we're talking about medians, okay? No other type of concurrency works in that way, okay? It only works when we're talking about medians. The last thing that we're going to look at today is the concurrency of altitudes. Nothing special happens here on the concurrency of altitudes. All that we have is that the 3 altitudes meet at a point. So the lines that contain the altitudes are concurrent. They meet at one point. So again, I'll try to... They always end up looking equilateral, don't they? So if I draw the altitude. So here's one altitude. Here's another altitude. Ooh, here's the third altitude, right? All this is saying is that they meet right here at a point. And again, that point is called the orthocenter, and that's what we just went over in our terms. But that's the only thing that's really special that happens about the with the concurrency of altitudes. They just meet at one point. So what we're going to do here is we're going to go back to the lesson, and we are going to do some examples. All right, so now we're back at lesson 5-3. And we're going to start here with example 1, which says, in this triangle, ABC, name the altitude and name the median. So which one of these is the altitude and which one of these is the median? So I want you to go ahead and try this one. If you need to look back in your vocabulary and your terms, that's fine. But I want you to figure out which one of these lines is the altitude and which one of these lines is the median. All right, so hopefully we looked at this and maybe we looked up in the back of our packet to see which one was which again. But the altitude, hopefully we found, was CE. So the altitude is always going to go from a vertex to the opposite side perpendicular. So it's always going to be perpendicular. It's not a perpendicular bisector, right? It's not saying that EB and AE are the same length. It's not bisecting it, but it is perpendicular to the opposite side. Which means that the median here is going to be BD. And remember, the median goes from a vertex to the opposite side and cuts that opposite side in half. So because AD and CD are the same length, BD is the median. So now let's look at example 2 where we're actually using this, okay? So we're going back to remembering that when I have 3 medians, right, that meet at a point, the shorter side times 2 gives me the longer side. So in this case, it's saying what is the length of J to N. So this whole length right here. Well, I don't know what the length of JN is, but I do know that JQ is 18. And I also know that if I take QN, so this short guy right here, right? If I take QN and I multiply that by 2, it gives me the length of JQ. So I can kind of fill in some information that then maybe I know. So I don't know what QN is, but I do know that JQ is 18, right? Because it told me that. So I can divide by 2, and that leaves me that QN is 9. So I can label this 9. So now I know that JQ is 18 and QN is 9. Well, J to N is made up of JQ plus QN. And now I know what both of those pieces are. I know that JQ is 18, and I know that QN is 9. So when I add those together, I get 27. So that tells me that JN is 27 units long. And that's it. So just remembering that the shorter side times 2 gives me the longer side. Okay, so you guys have 2 try-its here. So go ahead and pause the video and give it a try. They're pretty much identical to this example that we just did. So try it, and then when you guys are ready to go over it, go ahead and hit play and we'll review it. So let's look at this first one here. It says find A to D. Okay, and again, I don't know AD, but I do know AE, so that's cool. And so I know that because these are medians, that if I take ED and I multiply it by 2, I'm going to get AE. So I'm going to fill in what I know. I don't know ED, but I do know that AE is 21. So again, I'm going to divide by 2, and I get that ED is 11.5. And that's okay that it's a decimal. No one says it can't be a decimal. But I want to know the whole length, A to D. So AD is going to be equal to the length of AE plus the length of ED, right? The long length plus the short length. Well, I was told that AE is 21, and I found that ED is 11.5. Dogs. If I add those two together, I get 22.5 units. So the full length of AD is 22.5 units. And that's it. You did have one more. Try it. If you haven't done it yet, go ahead and pause the video and try it. If you have done it, we're going to go over it right now. Same thing, find AD. Well, again, I don't know AD, but I know that if I take ED and I multiply it by 2, I will get AE. So again, just setting up that equation. The short end times 2 is the long end. In this problem, I know that ED is 12. So I'm just filling in the information that I know. 2 times 12 is 24. So that tells me that the longer side here, or the longer length, is 24. But I want AD. So AD is the long length, which is AE, plus the short length, which is ED. I just found that AE is 24, and I was told that ED is 12. So when I add those together, I get 36 units. So the total length of AD is 36 units. So hopefully we feel okay about that, just the same practice over and over. If you have any questions or you need any help, just make sure that you reach out. Otherwise, that's it for 5-3, and good luck, and I'll see you soon.